Good day, everybody. Hey, it's Jason from Cequence, and I'm coming back with another bit about the bots. We're going to talk about bot attacks against your APIs and how we detect those automated attacks and how you can see what's going on with a transaction coming into your APIs that might be coming from one of these automated attacks or bots that are out there on the internet doing nefarious things to your infrastructure. Today we're going to go through just a little bit of intro. We're going to talk a little bit about the bots and how the different attack types work. We're going to look at the tools, infrastructure, credentials, and bot behavior that all of these attacks are going to have manifest against your application and against your APIs. There'll be a little bit of a demo of how we detect these things and what it looks like in the interface. And then we'll wrap it up a little bit with some Q&A and some additional resources and give you links to show you how you can try out our new solution that we have. By the way, I'm Jason Kent. I have been working in the security industry for a couple of decades now. I'm the hacker in residence here at Cequence. I'm primarily known for being the garage door guy. I open the Chamberlain garage door APIs and pop my door in someone else's, and went through responsible disclosure for all of that. I also work pretty extensively with Hackers for Charity. Been to Africa a few times, worked on a few projects there, and currently have projects going in Africa to help people. And it's a great organization. You should look into it if you're interested. Enough about me. Let's talk a little bit about the company. Cequence Security started up quite a while ago, and it has been gaining ground as it's moved along. We are a venture-backed organization. We have about 50 people in the company now, which seems weird to say. We're an award-winning AI-powered security platform. Our data sciences group looks at how attackers make packets and make requests to your environment, and we figure out ways to catch those, figure out the transactional intent behind it, and each transaction that comes into a web service or an API, we can analyze it and tell you if it's got a good intent or a bad intent, and then we can take steps to either mitigate that or we can correct it in some way if you'd like. The company has been focusing on web and API security for quite some time. I thought maybe we'd pause a little bit and talk about why APIs are kind of the next thing. So if we look at this rapid digitization of commerce that we're seeing that has taken up every organization across the globe, we've pinned a name on it called digital transformation. But really, what the digital transformation is, it's making commerce happen digitally. And so more and more organizations are adopting APIs to make it easy to communicate with them, with their partner organizations, with their vendors, with their customers, and they can build platforms that allow for all of this to function together. And so APIs are really driving this thing, and whether or not that API is used by a web application, a mobile app, whether it's B2B or C2C or any of those things, you can see that APIs are really the backbone, if you will, of the different platforms that are out there that most people transact with every day. I don't know the raw statistics on this, but the internet is a big place. APIs are consuming more and more of it, and we're starting to see some really interesting ramifications of that. One of the big things that we see with this is that the APIs are easy to get a hold of. It's pretty easy to find somebody's documentation on their APIs. It's pretty easy to go download a mobile app and take it apart and figure out what the APIs are out there. And it's pretty easy to attack these APIs, and that's what we want to talk about today. APIs are enabling these automated attacks. They're becoming the attack endpoints, but they're also making it so that the attackers can move faster. Because we're not having to render JavaScript in a mobile or in a website, We're not having to wait for a bunch of data to be transferred back and forth. APIs mean I send you a bunch of data, and then from there on, it's going to be little increments of data. But these are really compressible data files. Things move back and forth quite easily. And so the API infrastructure, which is usually maybe a public cloud, maybe a data center, who knows, but it's going to be having a bunch of services that run against it and use the APIs to get data, bring in data, all that kind of stuff. But we're seeing attackers use these APIs as the way to get into a lot of organizations. They go take apart a mobile app, they find that login endpoint, and they just start banging on it. And what we're going to do is talk about what that means and what it means to have an API sitting out on the internet that is being attacked over and over. As I said, the APIs, they help simplify the attack. So how am I going to find your API? Well, there's a bunch of different ways. There's open APIs, there's programmable web, there's going out and actually downloading the APK file for a mobile application and taking that file apart, finding all of the API endpoints inside of it, and using them. After we discover what's available to us as far as an API footprint, the next step in this is the attackers are going to create the attack. So they're going to either go out and download a tool, or they're going to fire up something like Postman or curl and start sending requests in. But probably the step right before that is they're going to use the service in a very legitimate way. Sign up for it, use a couple of things, poke around. Once the attacker has done that, then they have an understanding of what it looks like to make requests into the site. They move into this phase where they create an attack, and then they start to execute that attack using as many of the things that they have at their disposal as they can. So if they go download sniper config and they put in a username and password list and start firing it at your APIs, this is a great example of a workflow where they create the attack and execute it against you. APIs are pretty difficult to defend because they're really stateless. They almost have an entire transaction with them, with the exception of the TCP setup, but all of the data payload that goes along with it is going to be pretty heavy, and it's got all of the transactions inside of it. And oftentimes on the API endpoints, there's no agent or anything that's monitoring it. So it's really easy to go fire against it. You don't often see like a WAF or something like that sitting in front of an API because everything's going to be embedded in the post body. And the WAF's not going to take that. So once we have a good understanding that we have these APIs out there and we have possibly vulnerable footprint hanging out on the internet, we should have a good understanding of what the attackers are. And so understanding what a bot is pretty simple. An attacker sets up something that's going to make a lot of requests into your endpoint. Now this bot may be making requests directly, it may be using proxy infrastructure, it may be utilizing some third-party thing that goes along with all of that. But basically, you have to have a good understanding of these bots are automated attackers that have basically unlimited resources, and they can attack your organization at will, realistically. Bots are often responsible for all different kinds of attacks out there. Things like fake account creation, where we see recently we're seeing a lot of political stuff that goes on in fake account creation. People set up new accounts and they comment on sites, or they try to spread, malicious information around on the internet. And you'll see fake account takedown notifications all the time. And I actually have one in a later slide. Account takeover is something that we see, and it's pervasive. Even as COVID was happening and everybody was, locked up and going home and trying to make sure that we weren't spreading this disease around, attackers were still attacking as many of our financial retail customers as they could. We saw huge volume spikes on a lot of our customers Plenty to do when you're at work. When you're at home, I guess, time to write bots. I'm not sure. We also see things like denial of inventory and scraping attacks. We've looked at a lot of these kinds of attacks and kind of broken them apart into what it is that they're trying to achieve. But fake account creation, account takeover, and denial of inventory definitely are sort of right up the top. So account takeover attacks represent something like $4 billion in account takeover losses. How can there be a loss associated with an account takeover? Well, it could very well be I take over an account, there's a credit card tied to it, and I use that. It could very well be that my account gets taken over and I end up having to open a support case and work with your support teams. And any time I have to engage with individuals at your organization, it's costing me money. And so we're starting to see that kind of direct impact against organizations. But when we start to get to the point where I no longer trust you because this keeps happening to me, then you start to look at these indirect costs where you're just losing revenue. Right? Everything's starting to sneak away from you, and you'll see that it costs an awful lot more money to get new customers than it does to retain the old customers that you already had. And the goal should always be to retain your customers, keep them happy, and everybody else is happy with along the way. We see a lot of theft that happens with account takeovers and APIs, and this is a fairly straightforward example of an attacker attacks an API, gets a valid session token, and then uses that session token for an API call on a different channel. We've seen OFX channels, we've seen people transferring money from account to account. Once they have an authenticated session, if there's not a lot of protections on the OFX channel or on the rest of the API channels, it's possible to move money that isn't yours from one account to another. In order to make all of this work, obviously there's got to be infrastructure in place for the attackers. And if you look at the attacker components for automated attacks, you can see there's really 4 arrows in the quiver of an attacker, and we're going to drill into those in a lot more detail here in a later slide. But the 4 things are tools, credentials, infrastructure, and attacker behavior. And I'll drill into those, like I said, a little bit later. But APIs are becoming that thing that we go to in order to perform nefarious activities. Let's say I want to go scrape a website, right? I can easily set up a scraper that does a whole bunch of requests all at once, so I can be noisy, right, and go get every image off your page or scrape all of the prices that you have for things or whatever that activity is going to bear fruit on. But also, I can set it up so that I can dribble that stuff out of you. So I just simply make a request and I wait 2 minutes, and I make another request and I wait 2 minutes, and I make another request and I wait 2 minutes. Since I have all day and the bot's doing the work for me, I like to run it low and slow. It's not as noisy, doesn't light up your alerts, right? You're not going to notice. It's just me making requests. And these kinds of attacks are often the kinds of attacks that organizations come to us with and say, hey, how do we stop this sort of behavior? And we take a look at it, and you can see it right away. Using a bulletproof proxy network, or using some kind of bot that you can download off the internet. You see the signatures, you can see the fingerprints, and it's fairly easy to stop if the attacker isn't very sophisticated. From the attacks standpoint, we have all of these APIs set up, and we can, quickly establish new accounts on our platform by using a register page or using registry in an application. But we often see that fake accounts can get created. And Facebook just recently got rid of a whole bunch of accounts. And in fact, we just saw another list come through today of some militant groups that are associating themselves with various other militant groups like Proud Boys, etc. And they're going out there and spreading, misinformation or just communicating with each other, whatever. But these fake accounts can be a real problem, especially for a social media platform. But we also see it for organizations that are being surveilled. We create a fake account to see how does all this work. And it's good to know when it's a fake account and when it isn't. Inventory takeover and seat spinning, these are things that we really have to concern ourselves with. Sometimes when we talk about inventory takeover or a seat spinning bot, we're talking about somebody that's trying to deny services or deny someone else's fun, if you will, buying up all the new sneakers and then selling them on eBay for $10 more a pair or whatever. In the picture that I have on here, this is a really interesting story that came out of DEF CON a couple of years ago, where the lady that's pictured here, she bought an espresso machine and she was trying to find an espresso refills, and she found them on eBay cheaper than she could buy them from Nespresso, and they shipped to her, and they were valid, real Nespresso pods. And what she figured out was this is somebody that's buying them with stolen credit cards, taking the inventory from the distributor or manufacturer, and then reselling them at a discount, right? It didn't cost them anything to buy the stuff because they used stolen credit cards to do it, and then they resell it, and that actually makes them money. It's a great story, and if you feel like looking it up, it's a great time to watch. So in order for an automated attack to work, there's some components that have to be in place. The attacker is going to need tools, whether that's Postman or curl or Sniper or any of those things that are out there. They're going to have some tools. Credentials, almost always. We've got to log in with something. Infrastructure, something to run the attack, and an understanding of behavior. So they're probably going to play around with this thing first. If we look at the tools that they might have out there, there's a bunch of different kind of management toolkits to manage attacks. There's toolkits that allow for you to do things like check if a gift card works, or to check if a gift card number is good, if you're doing random number generation, or if you're carding off of credit cards or something, to see if it passes a Loon algorithm. So there's a bunch of these kinds of tools out there that will let you do these kinds of checks. They check to see if the username is available. They check to see all different kinds of things. And this list on the left, the attack management toolkits, are some of the toolkits that are available out there. If you have an organization that might be susceptible to this, you should be looking on those lists to see if they're out there. And then there's the custom tools, purpose-built. You can hire somebody to build them, or you can build them yourself. The infrastructure that an attacker is going to have is almost always a proxy network. Some of these proxies are server-based. Some of these proxies are completely static IPs. But more and more we're seeing residential set-top boxes that have been taken over, or people that are using free VPN services on their cell phones and their laptops. Those free VPN services aren't free. Most of the time, their terms and conditions allow you to become a member of the proxy network, and some attacker will be using your machine to attack someone else. Stolen credentials. We have to have credentials in order to make this work. Where can I get them? Well, there's a ton of places out there. Let your imagination run wild. There's Pastebins. There's all different places where people have posted things, GitHub, and you can go out and find credentials quite easily. And the attackers are going to need these in order to get into the system. And the last piece of this is the behavior. You've got to have the behavior set up so that it looks like a valid transaction. Sometimes there are embedded cookies or embedded elements in the JSON that allow for us to see, hey, this transaction should have happened 12 months ago, not now. And so understanding what that behavior is means the attacker needs to now go change that element so that it's not 12 months ago, it's now. And they need to work through those pieces. So I'm going to show you a little bit about what our solution can do by running a short demo of the solution.
All right, so we're going to go ahead and take a look at the Cequence security solution, or what we call CQAI. I'm going to take you through a little bit of a tour of the platform, and then we'll start looking at a few different things that will allow for us to hunt down a few of these threats and identify how the bots are operating. So we'll go ahead and get logged in into the console. Once I get logged in, I land on a dashboard, and the dashboard allows for me to look at various different things as far as how the bots are operating, how much traffic is flowing through the applications that I'm protecting. It allows for me to look at some of the metrics around the bots that are coming after our application. The first thing that I like to highlight is the Discover. If you look at the left side of this, you can see that we're starting to build sort of a sitemap tree. And this isn't a sitemap tree that's being generated dynamically by going out and scanning the application. These are actually the endpoints for web application, for APIs, etc., that are being touched. And this really allows for me to illustrate the power of sitting in line with this traffic that's going off to the application. It lets me see where the traffic is headed. And we can see in this, in the API selection, where the mobile app endpoints are and what's being exercised or attacked or utilized in some way. A lot of organizations have API endpoints for their mobile applications, but they don't have a way to enumerate them. They don't have a really good way to look at the API endpoints and how much traffic is going against them. And there are sensitive API endpoints that are out there that a lot of organizations may or may not want somebody to go up against. So for instance, we have account API activities that go back to a version 1 API, but there also seems to be a version 2 API that has account activities that are associated with it. Is this because we didn't deprecate version 1? Is version 1 being used someplace else? This simple activity of going and looking at the endpoints that you have allows for you to see, hey, we forgot to turn something off. And any time you look at security standards out there in the world, the first thing they're going to say is have an inventory. You can't protect the things you don't know you have. And many organizations have trouble developing the inventory of their API endpoints as well as their web application endpoints. And this really helps you do that. So going back to the bot detection, we can look at the information that's flowing in through this in kind of two ways. The traffic that seems to be normal, that looks like legitimate traffic, and then attack traffic coming from bots. Now in this environment, we've got our own bots set up and they're attacking, but this mirrors what a lot of our customers see. So as we scroll down here from the traffic volume statistics, you can see we have a way to pivot the information that we have flowing in. So I can switch this over to look at things like what countries are traffic being generated from or coming to me from. I can flip this to say, well, which ISPs are the loudest or the ones that are talking to me the most. And if I look for an example, we can do a little bit of a threat hunting activity by simply pivoting over to a user and start looking at the different users that are touching our applications and information around them. And this will really kind of drive us to the point of the 4 pillars because we're taking a single credential that may or may not be compromised, but certainly is known, and look at all of the activity that's happening on that one credential. Apparently, this person has 5 different user agents. They're coming from 1,000 different IPs, different geo distributions, different countries, etc. And so you can tell that this is a credential that's being used by a bot that's attempting to hit a bunch of different endpoints of ours. And we can see that they're hitting various API endpoints as well as they're trying to log in and they're probably trying to take over this account. We often see this in account takeover where one account is coming from all the different places and it's hitting the same login API endpoint. And the reason why it looks like this is the bot is testing this user against that endpoint, but they don't want to set alarms off. So they're rotating through probably a bulletproof proxy network and allowing themselves to look like they're coming from all over the place. But of course, if you're monitoring an end user, you know that they're going to be coming from a single IP for quite some time, and then they're maybe going to change IPs and they're going to come from that single IP for another block of time. If they rotate really quickly through the IPs, something's up. And we track that behavior, and one of our machine learning models understands exactly what's going on there and makes an attempt to flag that behavior, and then we send it off to the mitigator, which allows for us to cut down on it. So in order to sort of illustrate this, we're going to work this as if a case has come into support and somebody is complaining that they're seeing a bunch of login attempts against their username, and they're probably generating emails that say either you're resetting your password or click this link to reset your password. If you didn't try this, contact support, etc. So what I'm going to do is just simply filter out one of these users. I'll grab an existing rule that maybe is here, and I'll just flip the different username inside of it. I'll say I want this filter to apply, and it's going to apply. So now I can see that I have this one user. It's had a whole bunch of events against the application. It's come from 1,000 different IPs, 322 different organizations out in the world, and is rotating through 5 user agents. And if you look at this global distribution of where everything is coming from, it's pretty easy to understand that this single user is not coming from all these different places. Even if they're using, one of those VPN solutions where you can sort of pick where your endpoint is, humans don't do this sort of thing. They don't go bouncing through the world with 5 different web browsers and try to do things like go against the authentication service. So you might ask yourself, well, if this is a single bot that's using this this one username, don't you think that they're probably trying to go through a whole bunch of different usernames? And that's probably the case. So if we pull up some more details on this, we can drill into this thread a little bit further, and we can actually start hunting down where these attacks may be taking place. So as we scroll down through this information, we can see that this particular user, again, we're repeating the data, five user agents or 5 different browser types, 1,000 different IPs that this is coming from. And we start to roll down through here, and what we want to see is sort of uniqueness. And so you can see we're triggering on 2 different fingerprints. And if I want to go look for what else is happening against this fingerprint, I can. All I have to do is copy the fingerprint, go back to the dashboard, change my filter out. Instead of filtering on that username, I'm going to turn that one off, and I'm going to filter on a fingerprint, turn that on, and let the data rebuild. Now you can see that I've built a list of usernames off to the left side here that are indicative of the same type of fingerprint and the same type of traffic. What this is a bot that's iterating through these usernames and iterating through a bunch of different IPs, attempting to authenticate. And we can see right away who the accounts are that were impacted by this, and we can probably create some kind of proactive outreach and let these customers know, hey, somebody's attempted to log into your credentials, please make sure your passwords are good, etc. So it's a really great way for you to generate the information off of authentication attempts, block them so that they don't work, and then also have kind of an educational piece to it to allow for you to notify your customers, hey, we're seeing a lot of attack traffic and somehow they got your username. One of the other things that we can do is sort of flip that over, and we can start looking at all of the fingerprints that are in here. What I'll do is just simply turn that filter off so that I'm looking at all of them, because it's going to regenerate the data for me. And then you can see our attack bot fingerprints that we have. And so there's a few different ones that are out there. If you select them, you can see what they're doing. Most of them are authentication related, so these are mostly account takeover type things. We do have some things like scraping or API enumeration, things like trying to figure out, are these accounts real? We can also see behavior in here for denial of inventory and seat spinning. If you look at where these all are coming from and what they're trying to do, is you can see that what's happening usually is you're seeing a spike of traffic that comes in that usually attempts to either take over inventory by tying up some kind of checkout process or tying up inventory in some way. So from an account takeover, trying to get passwords reset and get the account taken over, or understand where the accounts are, inventory takeover, and doing things like web scraping where I'm sending in single requests, it's possible to see exactly what's going on against your application, against your APIs, and allow for you to set up some mitigations. If you wanted to try our solution out against your application, all you have to do is give us a call, and we're happy to set that up. You just need to send us a little bit of traffic. It doesn't necessarily mean that you have to send us all of your traffic or span all of the traffic coming into an application. You can send us a little bit of it. We don't have to sit it in line. We can sit up to the side, and we can really tell you what's happening inside of the application from a bot perspective. And it might, as I said before, give you a little bit of an operational advantage from a security perspective and allow for you to cut down on the amount of traffic that's actually going against the application that isn't legitimate.
Well, that was good stuff, and it's an interesting looking UI. Just summing up, understanding that Cequence looks real time at your traffic. We see it at runtime. We see it happening when it's coming in. We use machine learning architecture to fingerprint the bots that are out there and understand the traffic that's coming into your organization. We're going to stop now. All right, so on to the questions and answers part of this. If you have any questions that you'd like to ask, please feel free to drop them in the chat section there. But I've got a couple of questions that came in already. How do attackers learn about our APIs if we don't publish an API document? Well, that kind of reconnaissance happens through a couple of different means. I'll either instrument myself with an intercept proxy and look at the API calls that are being made. I can take apart the mobile application, especially if you have an Android app. I'll pull the APK apart and look at the API calls that are inside there. Or your website may actually make the API. Sometimes it's just guessing. If you have a V2 login, odds are there's a V1 login endpoint that's available for me to test against. All right, so the next question is, does Cequence find our APIs so we know where to deploy? You should probably understand where your web servers are and where you are deployed. We're going to instrument that deployment and look at the API calls that are being made. So if you meant to shut your V1 login endpoint off, we'll see traffic going against it and be able to tell you. But as far as where your web servers are, that's something that we rely on you for. And the last question is, if such a high amount of traffic is bots or attackers, can't we just use a CDN to stop them? CDNs really make a decision of, do I already have this piece of content that you're asking for so I can serve it back, or do I need to send this to the origin server? Now, there are some mechanisms that go along with CDNs to drop some of the traffic that is bots and attackers, but it's pretty rudimentary, and their goal isn't to stop traffic from going to your website. Their goal is to serve traffic faster. So if the bots and attackers are going faster, the CDN is just going to go faster. And so realistically, you got to have something that's looking at that transactional intent. If you have any other questions, please, like I say, let's drop them in the comments. If I don't get to them here, I'll be sure to answer them as I go along. And finally, if you want to learn a little bit more, we've got some resources that you can take a look at. We're developing more and more tools to help customers that have APIs. We recently launched API Sentinel, and if you'd like to take a look at that solution or any of our solutions, Please feel free to go to our website and check it out. Thanks for your time today, everybody. And once again, I'm Jason Kent, helping you keep the bots at bay.